Okay, hello, good morning. Okay, so welcome to 2271. All right, yeah, I have not had this LT for a long time. For a long time, I haven't had this LT. All right, after COVID, the only LT I got back was the COM3 MPH. Okay, so for this batch, you are the sort of biggest batch in quite a while. All right, so the past few batches has been maybe 60, 80, and so on. This batch is about 125 of y'all. All right, I think probably because we allowed y'all to co-read 2271 with 2028 and 402 as well. All right, so we allowed that so that the 402 doesn't get too big next semester. All right, so I hope those of you who have done it, okay, can map out your timetable. All right, so for me, you all know me, right? Okay, so you definitely would have seen me either for EPP1 or EPP2. All right, some of you may have been in my group, okay, so you know me better. All right, so 2271, okay, real-time operating systems is a module that has been going on for the longest time. All right, it has changed dramatically over the years. All right, so I will talk about a bit about that in a while. All right. So right now it is a nice mix of hardware and software, okay, in this module, and hopefully I am able to make it even better. So I'm planning some changes as well. All right, so if all goes well, you will be the first batch to have some new material as well, okay, and new things to do, okay. So that is probably towards the end of the module. Okay, so let me start proper first. All right, about me, okay, Mr. Ravi. All right, my handphone number is there, okay. I think EPP1, EPP2, all of you already know my handphone number, okay. So basically, most of my students will directly WhatsApp me if you want to ask any questions, but don't send a WhatsApp message where, you know, you go, then click read more, click read more, click read more, then I got five attachments to download. Don't do that, okay. If you have a long thing you want to clarify, you email me. Okay, send me the details, then we can discuss. Okay, if it's something short, okay, a simple clarification you want, you can WhatsApp me, okay, I will reply. Okay, if you want to discuss, okay, you can always come, make an appointment. We can either have Zoom or you can come to my office, COM20336. Okay, I think it's been very long since anybody come to my office to discuss. Okay, I think ever since we start Zoom, everybody just say, let's do Zoom. All right, so this poll, so you can go to the poll right now. So this poll, I started this last semester. I think it's quite a good thing. Basically, this link is permanent. So every lesson, you can go to this link, okay, and what will happen is you can type whatever you want, and I will see the questions. All right, so I felt that this is a better way for you all to immediately ask questions, because you may feel shy to shout out a question from where you're sitting. All right, so you just go to this link, all right, and you can ask me anything that's going on. Sometimes I get unrelated questions, okay, so I will try to answer as well, okay, if it adds value. Okay, so anybody want to try asking a first question? I don't want to show the screen first in case something inappropriate comes out. Okay, so let's see the question. Okay, why cannot be late for lab? You cannot be late for anything, correct? We give you a timing, means you must come on time, correct? Okay, so people ask this question. Your haircut is very nice, thank you. Okay, $16. $16 near my house there. Okay, used to be 12, then became 15, then became 16, you know. I don't know, by the end of the day, I don't know, it become 20, I think. Okay? Lab dress code, okay, this is important. You must wear covered shoes, same as EPP1 and EPP2. So all the labs are in the maker's lab, all right, so you must wear covered shoes, that is very important. So maker's lab, I don't know whether you have already had any labs there. It is not like our DSA lab. DSA lab, we have our guardian angel there, correct, Uncle Jalil. Anything you want also, he'll give you. You ask for oscilloscope also, he'll give you. Okay, everything he'll give you, okay? But Maker's Lab is a bit more sort of self-directed. Okay, so though we have staff there, the staff is not there to manage module. They just manage other lab stuff. Okay, so you need to manage yourself with what you have there, the resources there. You are free to make use of all the resources. Okay, so for Maker's Lab, by right, you all should have access. By right, you all should have access. If you don't have access, okay, you can go there. There will be a QR code. Okay, ask somebody to let you in first. There will be a QR code to scan and do the safety assessment. Okay, so once you do the safety assessment online quiz, then your card will be given access. All right, but again, it is not 24-hour access. You still have the same lab timing. Okay, so it's either 5 or 6. Okay, they will lock the lab, means they will lock the lab. All right, so make sure you do that. All right, so you have Maker's Lab access. You have 3D printers, you have laser cutters. You are free to use anything you like. Okay, so now is the best time to print or do whatever you like. It's there for you to use for free. No need to worry. Okay, nobody will stop you. All right. Okay, boards we are using. Okay, I will come to that in a while. Will we get lecture recording? Yes. So I've already asked for lecture recording. So by right, starting today is recorded. Okay, and it should be uploaded to Canvas. So Canvas, there will be a link there, correct? To you web recordings. So it should be uploaded once the class is over. Okay, so let's come back here. So I'll go through more details. But again, the poll is always active. So anytime you ask a question, it'll pop up here, then I can answer you all. Okay, so the teaching assistants, so we have 5 of them for the labs. Okay, so there are 2 lab sessions, okay, and 2 tutorial sessions. Okay, so basically, it seems a bit less consider the class size. All right, because what happened was originally this class was supposed to have only 60+ students. Okay, that was the original sort of allocation that we had, but suddenly it doubled, correct, because of this waiver that we gave. All right, and we initially wanted to open up more classes, but then we thought that it would be a hassle for you all, correct, because you will already choose this module based on the available slots. Okay, then if we ask you to go and choose another slot, then you have to go and rearrange your own whole timetable. Okay, so to avoid inconveniencing all of you, we decided to stick with the same schedule. Okay, so the labs will be a bit packed, but the Maker's Lab is big enough. So the Maker's Lab is big enough. Only thing is some of you may have the one half which is the seating side, the other half is the more of the working area. All right, but I think whichever side you sit is fine. Okay, tutorials we will manage by doing hybrid. That means they will be conducted in Makers and online at the same time. Okay, so those of you who want to go online can go online. Those who want to come to the venue, you can come there. All right, so that sort of helps us to manage the class size. Okay, so lectures, so this is important, the assessment part. So we have final exam, 40%, tutorial attendance, 5%, lab attendance, 5%, all right, midterm, 10%, and your final project, 40%. Okay, so these are all the different components that you have. So this module can fail or not? So far, we have had very, very rare failures. Okay, the very, very rare failures is people who disappear and don't show up. Okay, that means you disappear from the project, totally never do anything, cannot give you mark for the project. Okay, exam you don't come or something like that. Okay, so other than that, chances of failing this module is very, very rare. Okay, so I think as long as you do your part and you come, everything should be fine. So generally, most students do very well. Okay, usually I get appeal cases because students are not happy they got A-. Okay, they say, how come I never get A or A+? Okay, so usually the mark range is quite good. Okay, so it's a very competitive module. Okay, where everybody will feel that they are doing well. Okay, so I think it should be fine. So when is your final exam? Can somebody tell me when is the final exam? Have you all checked? So you all should know, I will not tell you. Okay, you all should know when is your final exam, you all should know where it is. Okay, so that you don't see the wrong schedule or the wrong date and wrong time. Can anybody share on the poll? When is the final exam? 2nd May, okay. 2nd of May. What time? 1 p.m. Okay. Okay, so make sure you check all this stuff and you know your timetable. Huh? Okay. Okay, so this detailed schedule. Okay, so I originally posted this schedule. Then on the canvas, I posted a timetable where the midterm date was changed, and then I changed it back. Okay, so we are still sticking to the original midterm date, which is 9 March, Saturday. Okay, so initially why I changed it is the office told me that 9 March I cannot have it because there is some other thing going on and asked me to change. Then after a while they come back and say it's okay. Alright, so I switched back to the actual day of 9 March. Okay, so this is the schedule. We will mostly stick to this plan, okay, in terms of weekly classes and lectures. So the flow is very nice. Huh? So when you come for lecture, you will learn the concepts, you will learn the basics behind it, and then when you go to the lab and tutorial, they will be linked back to the lecture. Okay, so you will reinforce whatever concepts we learn through the lab exercises and through the tutorial. Okay, so it's done in a way that everything is going in a flow. And what you are doing basically in the first half is basically understanding a new platform and trying to understand how you can develop your code and your hardware on this new platform. Okay, and once you are comfortable with this new platform, then we move on to the OS part. Okay, so the curriculum again has changed a lot over the years. So sometimes you look at past year papers or you talk to your friends before, it's all very, very old stuff already. Okay, so in the past, this module was run using Arduino Uno, okay, and free RTOS. Okay, that was in the past. And then when I took over, I said Arduino Uno is, you already know everything, correct? From EPP1, EPP2. So we changed to a newer board, more state-of-the-art, and things that are more relevant for you, okay, as computer engineers. Okay, so it is still evolving, okay, which I'm trying to add for this semester as well. Okay, you don't need any particular reference textbook. Okay, everything is available through our notes itself. Tutorials will start in week 3. Labs will start next week. Tutorials will be in week 3. Okay, so again, this will be face-to-face and Zoom. Okay, because of the class size. Okay, so what board are we using? So this is the board we will be using. Okay, which is the KL Freedom board, the KL25Z board. Okay, now this is based on the ARM Cortex-M0 Plus processor. Okay, and why we choose this board? Okay, or why we choose this board is because it is ARM, correct? And everything in the world is now ARM, correct? From your handphone to your MacBooks, okay, to every other handheld device is all using ARM processor. So putting that on your profile in LinkedIn says a lot more than saying that I know Arduino Uno. Okay, so please don't ever put in your LinkedIn profile that I'm an expert in Arduino Uno. Nobody will talk to you. Okay, say that you are expert in ATML328. Okay, that is fine. ATML328 is Arduino Uno, correct? But only the hobbyists know as Uno. We know as ATML328. Or you say I'm an expert in ARM controller. Okay, then it adds value to your profile. All right. So all this is important because you want to graduate with knowledge and information that makes you ready, correct, for the industry. Okay, and this is one of the steps you can take. Okay, so I sent in the announcement as well about the project. So 5-man or 5 people team. Okay, and the only restriction is all of them must be from the same lab group. Okay, so you have 2 lab groups. Okay, and you form your own team within the same lab group. Okay, so just to share, usually in EPP1, EPP2, most students complain about their team members, correct? Because you are randomly allocated. Okay, and they say, because of my teammate, I never score well. Or this teammate never do work one. Okay, never come for meeting, never do anything. Okay, I tell you, I ask you all to choose your own team, also got the same problem. Okay, every semester there will be some team that come to me and say, my friend never do his work. Every time disappear, every time do this. I say, you choose your own friend, what? Correct, but still got problem. Okay, so trust me, whether it's randomly allocated or you choose your own friends, still can have problem. Okay, so it's up to you to choose some teammates who you can work with. Okay, now what if you cannot find and form this 5-person team? Okay, don't worry. So if you cannot find, okay, if you have only 2 or 3 of you, okay, I have three friends, but I don't have 2 more to form a team. Never mind. when you come to the lab, then we will group you all together. Okay, so if a 3-person team here, another 2-person team, then we will ask you all to combine together. Okay, and then we will form a 5-person team. Alright, so if you don't have, then it's fine. You wait until the lab, and then we will help to sort it out for you all. Okay, so besides the KL25Z board, you will also be given this ESP32 board. Alright, so the use of this board so far has been to more or less act as a communication bridge, okay, between your platform, okay, your KL25Z platform and your controlling device. Alright, but in this, like I said, this semester I will try to give myself more work and give yourself more work, okay, so that we can have some additional stuff with the ESP32. Okay, so I originally intended, last year, December, I thought, okay, I will change the whole 2271 for you all. Okay, revamp the whole module, but then I was busy with other stuff. And then delay until got no time. So I decided, okay, never mind. The revamp part I will do later. For now, we do this first. Okay, so we bring ESP32 in, and we will add some additional stuff for the ESP32, okay, where you will learn something else besides just using it as a bridge. Okay, so for the project, okay, you will be issued the entire project kit next week itself. Okay, so next week itself, once your team is formed up, we will issue the whole project kit. Okay, so please take care of it. Don't go and sell it on Carousel. Okay, I don't want to see it up on sale. Okay, and you will use the different parts of this kit along the way. Okay, like I said, the first half of the semester is giving you the opportunity to learn the board, learn all this stuff, and build up all the backbone of this whole system. And then when we bring in the OS, you just complement the whole system with this whole OS architecture inside. Okay, so let's see exactly what this project is about. So maybe you have seen your seniors do some of this stuff outside the Maker's Lab. Let me see the video. So that was from your seniors. Okay, so that student there, Neil, he has graduated last year. He joined us as a full-time TA. Okay, but he joined the engineering side. Okay. Okay, so was it fun? Do you like it? Okay, so the project is quite fun. Okay, I think most students enjoy doing the project. Again, that is the fun element. So you just don't learn stuff, do experiment, but you work towards something that is fun, where you see everything come together. Okay, so that's the idea of the project. Okay, so I hope you all also have fun working on it. Alright, so like I said, this module, we have advanced embedded systems, microcontroller concepts together with real-time operating systems. Okay, and again, towards the end, we will try to bring in some other stuff as well, okay, with the ESP32. Okay, so again, primarily everything is on Canvas, no need to go anywhere else. Okay, some motivation on why we need to do all this. Alright, so if you look in the news, okay, there is a lot of developments or investments in Singapore, okay, by many companies, alright, where we will need people like you all, correct, computer engineers, software developers, and so on. Okay, so in terms of, okay, this solar plant, okay, energy, battery, and so on. Okay, now some other motivation. Okay, this one I took it some time back. Okay, so Tesla is doing okay, but currently under a lot of pressure from BYD. Okay, but if you look at your potential future job that you may want to apply for, okay, as an embedded firmware engineer. All right. So what are the requirements? So let's look at the requirements that they look for. Bachelor's degree, you will get in a few years' time, correct? Okay, 1 or 2 years' time you will graduate, you have your degree. 3 years plus experience, I'm sure you can say one. You already work on embedded for so many years, correct? So you just say I have experience. Okay, hardware, embedded systems, all of this you good. Solid background in embedded systems and developing C. Even if you write 2 lines of code, you still say you're solid. Correct? You still say you're solid. Okay? Trust me, nobody tells the truth in their resume one. Okay? Your resume will only be about 60% true. Okay? And then what do? You wait for somebody to call you for interview. Then you study the other 40%. Okay? So as long as you study and you're prepared enough for the interview, then you get through first. Then you realize you still don't know a lot of things. Then you study a bit more. Okay? And then you do the job. Okay? Experience in RTOS, which is what you're learning in this module. Okay, and maybe in some other modules as well you might learn. Okay, actuators, sensors, all of this. Okay, I think from EPP1, EPP2, this module, all of this you have learned. Okay, and high quality code. You just take the best code you have written and put on GitHub and say, please look at this. Correct? So you can see that whatever you are learning is applicable to what you want to do in the future. Correct? Even if you don't join a company, you have your own startup, it's still the same thing. Correct? You still need to know your stuff to build something on your own. Okay? And if you look at this other job, also Tesla, also the same things. C, embedded development, C, Mistral C, debugging, microprocessor architecture for ARM. Okay? So all of these are important skill sets that you need, all right, when you want to graduate. Okay? Now, this is another job. This one I just saw 2 days ago because I just wanted to check again how is the market for Tesla. Okay? And they're still hiring. Okay? And again, they're looking for the same skill set. This is exactly 2 days ago. So again, the same thing, embedded systems, C, software design, microprocessor tools, control systems, and all this stuff. Okay? But one of the reasons why this job opportunity came out strikingly, okay, is because of this. Okay, this is crazy amount of money. Okay, and US dollars. So after looking at this, I've decided to update my resume. Okay, so if you don't see me around when you graduate, you know where to find me. Okay? Okay, so this is an extremely high package, okay, which means that there is a market, there is a demand. There's a demand for computer engineers, software developers, and people who have this skill. Okay, so trust me, even though the whole world is very hyped up about AI and ML and all this stuff, ultimately remember, the computer make the decision, but still somebody must do the stuff. Correct? So we still need a lot of engineers to build systems that can tap on to what the AI or ML tells you. Correct? Okay, so yes, there is one part that is very popular now, everybody's talking about it, but again, you still need this other part to develop a complete system. Okay, so you have a lot of potential. Okay, so no need to do the poll now. Okay, so this is important. Okay, so after all this module that you do, so this is the first lecture, so we have some time to talk other stuff as well. Okay, so ultimately when you finish everything, this 3 years, 4 years, what's the end game? This is the end game, correct? So this photo was taken last July, the last batch that graduated. Okay, so we were there. Okay, and we managed to gather all our CEG students, come together in the other hall and take one very nice photo. Okay, so what happens after you graduate? Correct, when this moment comes, of course your parents will come, they will cry, oh my son, my daughter graduate. Correct, they'll hug you, take photo, everything. So it's a very nice moment, very memorable. Okay, all your family, all your friends will be there. Okay, so of course you enjoy this moment, you cherish it, you look forward to it. Okay, but what happens after this? Correct, what happens after this is what you decide to do. Correct, what you decide to do. Okay, now let me tell you a bit of story. So again, this storytelling, my history. So you understand a bit of me and where I came from. Okay, so I was clearing off my stuff, so I managed to find this paper 20 years ago. 24 years ago, year 2000. Okay, that time it's still pen and paper. So when I got accepted to NUS, so I say, okay, I'm doing NS. So they give me this. So they reserve the place for me, so after NS I come. So this 20-year-old paper I still have with me. 24 years old, correct. So this is what happened to me, correct? So I joined 24 years ago here, but not here, not engineering side. Okay, so my time, nobody wants to go computing. Okay, computing is considered a dumping ground. All the C's and D's go there. Okay, all the top students will go to engineering. Okay, and the engineering batch was very, very big. I think almost 800, 900 students per batch. Just electrical and computer engineering. Okay, so that was like the most toughest course to get into, and they split the class into 2 groups and so on. Okay, so when I joined NUS, okay, though it's called electrical and computer engineering degree, when anybody asks me what degree I'm doing, I say I'm doing a maths degree. Right? Why? Because my whole time I'm just solving maths equations. Okay, every subject is solving maths equations. Signal processing maths, image processing maths, control system maths, everything is maths. So much so that, I was not doing anything else, correct? Until I did one module, okay, where I found my passion. And what was that module? The module was called, the code is what? P208 or something. I think I don't know if I still have it or not. Okay, it was called Embedded Systems Design module. Okay, And it's a fully project-based module. Okay, no test, no exam, nothing. Just do the project. Okay, but everybody is scared of the module. Okay, why you're scared of the module is because the project involves you building your own computing processor board from scratch. Okay, that means you take the actual processor, your power system, your memory, everything. You hook up all the address bus, data bus, control bus, and you do everything just to make your computing system up and running. And when that is running, then you actually start the project work. Okay, so it is a nightmare in terms of the whole work involved. Okay, so I was again clearing all my stuff, so I managed to dig out some stuff that I managed to find. All right, so these are some of the drawings that I did. So I had to lay out 4 pieces of A4 paper, put scotch tape. I see the line here, all this is scotch tape. So I scotch tape 4 pieces of paper and draw out my whole circuit. Okay, this is just 2 papers I could find. I couldn't find the other paper. Okay, so you can imagine there are like maybe about 800, 900 wires to wire wrap. Okay, to get the whole hardware working. And after the hardware working, then you write the software. Okay, and imagine out of 800 wires, 1 wire goes wrong, that's it. You will die troubleshooting. Okay, but it was a crazy project. Okay, but I really loved it. And the lab staff liked me so much because I'm there before the lab opened, and I refused to leave after the lab closed. Okay, the lab opened at 8 o'clock, 7:30 I'm outside with my toolbox. Okay, 5 o'clock they will chase me out. Ravi, go back home. Ravi, go back home. Okay, so much so that the lab staff were very nice. They know I will definitely be back the next day. They take my toolbox. I keep for you. Going to bring back home. I keep your toolbox for you. Tomorrow morning you come and continue. Okay, so this is my story. That means why I choose to go in this direction, because I found something that I really like along the way. Okay, so of course for you, I hope that you also find something that you like in this journey of yours, if you still haven't found it. Okay, so what if you don't find your passion or it lies elsewhere? Okay, so let me tell you another story. Okay, for during my time in the last year, there are 2 compulsory modules that all engineering students must take. One is called HRM, Human Resource Management, and the other one is called Law. Okay, they say all engineers must know law. Okay, do you all still study law? No need, so for us, it was a compulsory module. Okay, and they engaged this practicing lawyer to come down on Saturdays to give us this law class. So it will be a full day class. Whole morning is all lectures, and whole afternoon is all discussion and other stuff. And that is the only class where it was full attendance. Okay, why? Because everybody just was happy to not solve equations. Okay, and look at words and sentences and things like that. Okay, so everybody studied law, and it was a very nice module, because you learn about, all these other, the legal terms, so I can't remember also, tort and things like that. Okay, so it was very nice. And one of my friends, my batchmates, he was so sort of excited about law that after he graduated, he convinced his parents to send him overseas to do a law degree. Okay, so he finished 4 years of engineering, went overseas, did another 4 years of law degree, came back and became a lawyer. Okay, so that was his story. A lot of other friends of mine did other stuff, but actually I'm the only one who became an engineer. Okay, none of my other friends became an engineer. Okay, so all of them did other stuff. That means they went into civil service, they did administrative work or managerial work. Some of them became other things. So I think you will find your way somewhere along the way. All right. So if you haven't found it yet, at some point of time, you will figure out, okay, this is what I like, this is what I want, and then I will pursue that passion. Okay. So that's the storytelling time. All right. So far, any questions? Anything? Okay. So let me just quickly run through the project specifications. Okay, which I have uploaded. Let me see. Okay, so from the video you see that there is an embedded platform you must build. Okay, and you must control this embedded platform using a remote controller. All right. So in this particular case, the students build an app to do it. But along the way, we are flexible that you can do anything you like. So people have used your PS controller okay, or you can build your own hardware controller, anything. So as long as you are able to develop something that you can control your robotic car with, okay, that is fine. Okay, and eventually your car must be able to navigate that whatever maze that we give you in. Okay, so the requirement checklist is quite easy. It's just to make sure that all the basic stuff of your robot you can fulfill. So things like the direction, LED control, audio control, and so on. Okay, so I'll just give you an overview first. So we'll come back to this at a later time. All right, this task architecture all we will come back at a later time. You need to submit some video. Again, it's just as a reflection of what you have done. Okay, don't need to worry about that. Okay, so this is the old, this is a challenge run sort of layout. Okay, again we will customize this based on the one outside the maker's lab. Okay, and in terms of grading, okay, you will have 4 attempts. Okay, again, it is up to you how many attempts you want. We will take the best attempt. Okay, but the first 2 attempts you can do immediately. But subsequently, if you have any hardware issues you want to fix, then there is some penalty that we will add. Okay, so this is just to give you an idea of the overall project. Okay, but the details of the architecture and the hardware, we will revisit it later on once we have covered more stuff. Okay, so let me continue. Okay, so today the first lecture, so we will not go all the way. I will do just this one lecture, okay, and then we'll end early. Can? So I won't have a break or anything, so we'll just probably take another 20 minutes or 25 minutes, cover this basic stuff, and we can end early, and then next week onwards we will pick up the pace. Okay, so let's cover this. Again, the poll is always open, so if you have any questions, you can put there along the way. Alright, so what is an embedded system? Anything that is self-contained, okay, as a computing platform, okay. What you did in your EPP1, EPP2, that is also an embedded system. Your simple, this microphone that I'm using is also an embedded system. Your aircon remote control is also an embedded system, okay. So it doesn't matter whether it's a high-end or low-end, as long as it is a self-contained computing system where you build it for a specific purpose, then we say it is an embedded system. Alright, now how can I build an embedded system? Alright, so of course, in our case, we are looking at this, okay, the microcontroller-based platform, which is same thing as your Arduino platform or the ESP32 that we're going to use, where you have a processor already prefabricated with all the essential subsystems, correct? Your power, your GPIO, your timers, okay, your ADC, your DMA, all this stuff is already built together, okay, as a single chip solution, all right? So that is, of course, a good starting point. Whenever you want to start a project, you want to create a project, you take that as a good starting point, all right? Now, if you have the resources, okay, then you can go on to building your own custom design, okay? So that is this, all right? So what is the difference? The difference is your cost will go down a lot. Okay? So if you have a plan, let's say you are working on a startup company, you have a prototype, you build something. Okay? So in the prototyping phase, you use a readily available board, correct, to get the proof of concept. But once that is done and you know that, okay, I can move on to the next phase to make the cost lower, okay, the footprint smaller and so on, then I can build my own embedded board, okay, with the microprocessor and so on. Then you also have the other option of FPGA. Okay, so FPGA or programmable logic is basically where you write code that will translate to hardware. Okay, so this is where you will learn about computer architecture as well. All right, so this module, okay, is 3207, I think right now. Okay, in the past it used to be a compulsory module. Okay, which I wish it was, but because of the merger, okay, when the CDE merger, this module now become optional as an elective. All right. So even though it's elective, I will still strongly encourage you all to take this module. Okay, 3207 if you can fit in your timetable. Why? Because in this module, okay, you will learn something called HDL. Anybody knows what is HDL? Yeah, so I heard some. Okay, it's called Hardware Description Language. Okay, and what does Hardware Description Language mean? That means you write code. Okay, you write code that will translate into actual hardware. Okay, it's like Lego building blocks like that. Okay, you write code, you build a block. You write another code, you build another block. Okay, it's actual hardware block, and then you interlink the blocks together. Okay, so that is basically how your processor is made. Okay, and why do I say take this module? Because this is one of the domains that is very niche to computer engineers. Okay, and I can tell you there will be a strong demand for this. There is already a strong demand for this right now, and it will continue to grow. Okay, because if you look at the processor market, NVIDIA is now the lead, correct? And of course, they're putting in a lot of resources to integrate AI into their chips. Okay, but definitely there will be a lot of competitors coming up. Okay, which means there will be a lot of investments, okay, and job opportunities for those who know this language and know this skill set. Okay, so if you can take up this module, okay, and learn HDL, okay, it will put you at an edge over those who don't have it. All right. Now, after you have FPGA, it is still an expensive solution. Then, if you want to mass produce a few 100,000 units, then you go to ASIC. Okay, so you custom build your own ASIC. Okay, so for example, in all your handphones, they say this is my A9 processor, A7 processor, and so on. That is a custom-made ASIC chip, okay, that is fabricated with some processor core and all these subsystems all integrated inside. Okay, so this is just a simple example of an embedded platform like a bike performance tracker, okay, where you want to keep track of how fast you are riding, how many revolutions of your wheels have turned, and so on. Okay, so this is a very simple device, monochrome display, maybe a few buttons, and so on. Okay, and for something like this, you just need a very low-cost microcontroller. Okay, so when you are a student, okay, generally you can use the boards that we give you, okay, and you just use whatever is readily available, correct? But if you want to design something on your own, you want to keep your cost low, okay, which means you want to choose a platform where it is most optimal for whatever you are designing. Okay, if you take another high-end application, for example, ECU, okay, for automobile unit. Okay, ECU for automobile unit, you need a lot of processing power. Why? Because you have a whole bunch of inputs, okay, that you need to process and make some important decisions, and from there you move on to generate some outputs and so on. Okay, so in Singapore there are a few automotive companies also very active in embedded firmware and so on. You all know any companies? The names? Based in Singapore? They have quite a well-established presence. Automotive companies. Okay, so one of it is Continental. Okay, they have grown quite big here. They started off quite small, but over the years they have grown a very big R&D office here. Okay, the other one is Delphi. Okay, I think they recently changed name after a merger or whatever. Okay, so they also do a lot of Delphi is a spin-off from GM, now General Motors. So they also have been in Singapore for many years. Okay, so when I was a student, I did my internship here at Delphi. Okay, so I still remember. So we had to write some application to monitor the ECU, all the data packets coming through the ECU, and do some display and things like that. Okay, so it was quite a nice experience, and I learned a lot about all this stuff. Okay, so if you are designing a system to be ECU in an automobile, you need a lot of inputs and outputs and a lot of processing speed, so you want to go for a high-end device, a 32-bit controller with high speed, lots of memory, and so on. Okay, now what is Mistra? Does anybody know what is Mistra or Mistra C? Heard of this name before? Okay, so C language all of us know. Okay, all of us know what is C language, but certain industries have their own rules of how you can use C or any programming language. So Mistral C is actually a variant of C where they have certain rules that you can only program your application within these rules. Okay, so even though, yes, as a software developer, you can solve the problem in many different ways. Okay, but if you want to develop code for example, the automotive industry, there are certain rules to apply. So you cannot do certain things, you cannot have certain type of pointers or things like that. Okay, so that is Mistral. You can go and read up on that. Okay, these are just again some general stuff, just to give us some idea. So again, embedded device is for us to give us a single sort of portable solution for whatever we are trying to solve. Okay, so again, these are some of the examples. Okay, signal processing, communication. So your router is also an embedded system. Your set-top box is also an embedded system, and so on. All right, and in most cases, you will have many embedded systems talking to each other. All right, so if you take a car, for example, there are so many subsystems all talking to each other. Correct, you have your ECU, you have your aircon control, you have your audio system, okay, you have your lighting control, you have your mirror control, and so on. Okay, so everything talks to each other. Okay, so let's look at this simple example here. All right, where you want to interface an analog sensor. All right, so if I give you this information, all right, that the relationship between the pressure, okay, and the voltage here is given by this line, very nice straight line. Now what you can do is, you can easily represent that line, okay, using a formula here. Alright, you can take that information and represent it using a formula, okay, and then use that formula to know that, okay, if I read this analog voltage, it translates to this amount of voltage, this amount of pressure, and so on. Okay, so it's easy to relate to it. And of course, in this case, we talk about ADC. Okay, so in EPP1 and all, we talk about the ADC range, what are the signal processing we can do to maximize the range, and so on. Okay, now if, for example, if the relationship is non-linear or disjoint, then what do you do? Okay, so what do I mean by non-linear or disjoint? That means instead of something like this so nice, what if the relationship was something like this? Okay, let's assume that you have some very funny relationship. Okay, then what do? You can spend the whole night trying to derive a mathematical equation that represents this entire line, correct? Okay, which is possible. Okay, or you can do what we call this. Okay, what is this called? Okay, it's called piecewise linear. Okay, that means you break up the whole problem, a non-linear problem, into small problems that look linear. Okay, and as long as it's linear, it's very easy to solve, correct? Okay, but when it's non-linear, it's more challenging. So if I break up a problem, then I can make the whole problem piecewise linear. That means I can say that, okay, from here to here, okay, from here to here, I can represent it by a line here. Okay, approximate line. Here to here is another approximate line, and so on. Okay, so instead of trying to make it very accurate, okay, you try to make it as close as possible, but with some margin of error which is acceptable. Okay, so that is, that is what engineers do, all right? We don't try to solve all the problem. We solve the problem until you can finish your presentation. After that, you can crash and burn, it's fine. Correct? So that is the objective, correct? You want to solve the problem until the objective. Okay, you have to demonstrate to your boss until that time it must work. Okay, after that, it never works, never mind, later you fix again. Correct? So it's the same thing. So as engineers, we try to solve problems in a practical way. Okay? Sometimes we know the ideal way, but we may not have the time. Okay? Because for me, for example, when you're in the industry, okay, when your product is going to be shipped, okay, before it's shipped, you have to go through the manufacturing line. Okay? Have you all been to a manufacturing line before? Okay, who's the biggest manufacturer in the world? You all should know, biggest manufacturer in the world. Everybody knows this, right? The biggest manufacturer in the world. Nobody? Foxconn. You all know Foxconn, right? the one who makes all the iPhones. Okay? They are in China. Okay? I didn't visit them. I visited Venture in Malaysia before. For Foxconn, my colleagues last time I visited, they tell me their plan, that means the land space that they set aside, let's say, to build iPhones, that land space is equivalent to one estate in Singapore. So imagine the whole of Clementi, for example. That is the land space they set aside for all the factories that just build iPhone. Okay, they are massive. Okay, so if you ever go to a manufacturing plant, okay, you will see rows of people just standing and everybody is just doing a few tasks only. That means the worker is just there, like that. Okay, they wait for the next thing, they do the same task, then the next thing comes, they do the same task and goes. Okay, so every second is money, correct? Because everything is moving like clockwork. So imagine that suddenly, while they are doing the manufacturing line, they discover there is an issue. They have to stop the whole manufacturing line. And to stop the whole manufacturing line is a lot of money. Okay? So no developer, no company want to stop the manufacturing line. Okay? So if they discover something in the last minute, what they want to do? They want the quickest fix possible. Okay? The quickest and easiest fix. Okay? So that the customer does not realize the problem. Okay? You have to understand, we all buy defective products, correct? Whenever they say they upgrade, are they upgrading? No, they're fixing the problem that they gave us. Correct? They ship us a defective product, we pay for it, but then they say it's upgrade. But it's not upgrade. Correct? They are fixing the defect that they gave us, only thing they're taking their time to fix it. Correct? As long as we are not too disturbed by the defect that we bought. Alright? So that is how engineering works. Okay? So this is another common thing. The difference between microcontroller and microprocessor. Okay, this is a common thing. What is a microprocessor? It is the core. Okay, it is the core that does the brains of your whole system. Okay, so in our case, it is the ARM Cortex core. Alright, that means it is the main brain of the whole system that is responsible for executing your instructions and giving you the result and so on. Okay, but that alone cannot function by itself. Okay, that alone cannot function by itself. In order for it to function, you need all the subsystems, which is your memory, your power, your clock, okay, then your I/O and so on. So all this other stuff comes together like this, and this whole thing here is what you call the microcontroller. Okay, so when you buy your Atmel 328, your Arduino Uno, or you buy this KL25Z, what you are buying is you are buying a readily available controller with all the subsystems and also additional pinout brought out for you. Okay. If I want to just focus on my solution, then I take out the controller alone. Okay, without all the subsystem. So all this we will talk about it along the way. Okay, so again, real-time response and performance again depends on what you are doing. Okay, all this we will cover when you come to the real-time part. Okay, so currently, do we have real-time capability in our microcontroller? Yes, we do have. Why? Because our hardware can run independently. Correct? If you remember your earlier modules, if I configure a timer module to give me an interrupt every 1 second, it does it by itself, correct? Okay, because the code that I need is only the initial code to set it up. But once I set it up, the timer will give me the interrupt by itself through the hardware. Same thing for PWM or for serial interface. Okay, so right now, you already are doing concurrent development, correct, or real-time development using hardware. Using hardware as a tool, you are already able to achieve real-time performance. Okay, but because it is hardware-based, you are limited. Correct, you're limited by the hardware that you have. Okay, so if I have, 3 timers, then I only have 3 timer modules to give me 3 different types of interrupts. Anything more, I'm stuck, and so on. All right, so you have interrupts as a way, okay, to do this, but it is still limited. Okay, so if you look at this example, okay, I can say that I have a timer interrupt, okay, and every time the timer interrupt trigger, I start the A to D conversion and I perform a certain number of conversions every time the interrupt trigger. And once I have enough ADC conversion done, I wait for the next timer interval. Okay, so for example, I can say that every maybe 100 milliseconds, I do 4 A to D conversions and keep the result. Okay, something like that. So I can perform this whole action, okay, every 100 millisecond for ADC interrupt, every 100 millisecond for ADC interrupt, purely through hardware alone. Correct? Just do the initial setup and eventually everything is taken care of by the hardware. Okay? So, of course, beyond embedded systems, one of the things is also fault handling. Okay, we want to be able to handle faults in a case where you do not accidentally do harm to the user, all right, or crash the system that causes any sort of failure beyond what you expect. Okay, so this is also important because how do you handle faults in a gracious way that you do not affect the integrity of the system or you do not affect anybody's lives or whatever. Okay, so this is of course very important depending on the application of the system. Okay. Okay, cost, size, power, okay, all of these are things that, again, right now you may think that it is not so important, but if you have your startup or you start a company, it's very important. Okay, in the industry, you want to add one resistor, also you must justify. Okay, why? Because one resistor is maybe 1 cent. You imagine 1 million products, 10 million products, correct? It's a lot of money. Okay, so add one resistor or change some design, do anything, all is cost. Okay, so you need to be able to justify. And the size, the weight, the power, okay, how long your battery can last and so on. Alright, so all of these are important. And of course environment as well. Okay, some countries are very, very cold, some countries are very, very hot. Okay, how well can your product be used in this kind of country? So all of these are things you need to also factor in. Okay, so in embedded system domain, generally, C is still the number one choice, okay, because it is able to map very closely to your hardware. Okay, so yes, you have a lot of other languages, which is good, okay, which is good for your profile, but for embedded system, most of the industry is still using C, okay, it's still the preferred choice. Okay, so coming back to our board, okay, this is the 32-bit, okay, Cortex M0 core. Alright, so it's quite a high-end board. Okay, so let me tell you a story about the board. So this board, you've been using it for at least 4 years or so. Alright, and last year, January, I placed an order, okay, for the new batch. That means I'm talking about 2023 January. Okay, so suddenly at that time there was this huge, all over the world, this supply chain issue with electronics, global electronics and so on. So I couldn't get it in time for the last batch, okay, in July. They said that it will only come in August or September and so on. Okay, so I had to call all my old students and say, can you all give me back some of the boards? Okay, so thankfully all very nice. Okay, all came back, gave me, and then we were able to run the class. Okay, so the boards were supposed to arrive last July, shifted to September, shifted to October, shifted to December, and December they said, oh, you will come in December 2024. Okay, so this one was told to me like in December last year, correct? And then your class is here, right? Correct? So December I was thinking what to do, correct? So I only two options, correct? Either I find some miraculous way of getting these boards, or I change everything that uses another board. So I was contemplating both. Okay, then Mr. Chan from the tech services, he helps me with all this stuff. So we are checking through, and then we managed to find some supplier in China who is selling these boards, which we ordered from. Hopefully it works. We will know next week. Okay, if it doesn't work, then I don't know. You will have a plan B, which I have to think about. But it should work. It should work. Okay, so next week when we collect the boards, okay, and you start your lab, we will know the truth, what is going to happen. Okay, but I trust that it will work. Okay, so we will use this board, okay, with all these peripherals built in. Okay, again, for project-wise, we are only going to give one board per group. Okay, I will try to get in more boards. Okay, once we are able to confirm that the boards are okay, I will request for more boards. But for now, we will issue one board per group. Take very good care of the board. Okay, don't touch it. It's quite sensitive, so don't touch it if your hands are damp or wet. Okay, make sure your hands are clean, okay, and dry. Okay, and you need to solder the header pins. This one I will talk about it next class. Okay, so I will be updating Canvas, okay, with all the project teams. Okay, so I will open a total of 25 teams. 25 teams. Okay, and once you form your group of 5, you can just choose any team number. Whatever is your lucky number, you go and choose. Okay, and you go and register. All right. So don't go and like choke with tissue paper. Go and each of you go choose different number. No, Okay. Once your team is formed, you decide what's the team number. You go and choose. Doesn't matter. You will still just go in order only. Okay. So make sure you register only after you form your group. Okay. If you haven't formed your group, then don't register first. Wait until the lab. Okay, and then we will help you to form your team. Okay. So no changes are allowed. Okay, so once you choose your teammates, okay, you register, that is your team for this module. Again, it must be in the same lab. There's 2 lab groups, so just choose anybody in the same lab group. Okay, if you don't know, wait until the lab, we will help you. Okay, so next week, what is going to happen? Next week, you all must come to the lab. Okay, next week you come to the lab, and each team will receive 1 freedom board. Okay, not the whole team doesn't need to come. Maybe if you are not able to come, at least 1 or 2 of you will come. Okay, to collect the stuff and collect the board. And once you collect the board, you must do lab 1. Okay, so I have uploaded lab 1 and the software, the Kill IDE software you need to install. Okay, the Kill IDE software currently is only supported on Windows. Okay, for Mac users, okay, one of the previous batch students figured out a very long workaround. Okay, I will share the link with you all. Okay, so those of you who have Mac, if you cannot do dual boot or parallels or whatever, then you can try that approach and see if it works. Okay, so next week, if the whole team doesn't come, it's also fine. At least 2 or 3 of you come to the lab to collect the stuff, collect the board. Okay, if you haven't formed a team, then you must come to the lab. So I can help you all to group together. But you already have your team, you have already registered your team means, then maybe 2 or 3 of you all just come, collect the stuff, test the board. Okay, test the board, make sure the board is fine. Okay, and then you can go after that. Once the board is fine means you can leave after that, you don't need to stay. Okay, so we will also issue all the components. If there are any components that are not there, that means we will wait until the stock has arrived. Okay, but I think most of it is there. Okay, so any questions so far? Anything that anybody wants to ask? No? Okay, so we will have the Kahoot. Okay, so for the Kahoot, like I said, there are prizes. Okay, so last batch, I only used to give the prize for the top winner, correct? So this time, I decided to give the top 3. Correct? So what are the prizes? Let me just show you. Yeah. Okay, so the winners get Arduino Uno each. Okay? Okay, so why you don't want? Okay, so the top 3 prizes so the third prize and second prize we get Arduino Uno. The first prize only for this week, got a mystery prize. So the first prize can choose between mystery prize or the Arduino Uno. Okay, what is the mystery prize? I can't tell you. It could be a box of chocolates. Okay, it could be nothing. Okay, so if you want to take the risk, you can take the mystery prize or you can take the Arduino Uno. Only for the first place winner. Okay, Ken? Ready? Okay, so let me set up the... Okay, so I'm not sure how many of you are here. I have to tell you a disclaimer first, because Kahoot is not free anymore, correct? It's charged. So my license only allows 100 participants, so I'm not sure whether it's more than 100 here. So it's more than 100 means fastest fingers first. Huh? Okay, wait around. Where's the volume? Oh, I didn't know I'm inside also. Okay, so I think it's lesser than 100, so it's okay, should be fine. Okay, so yesterday I already sent an announcement. The topics will be a bit of your electronic stuff from EPP1 and a bit of C programming stuff. Correct? Yesterday I sent an announcement, so you are a bit prepared for that. Okay, anybody else? All good? Shall we start? For 88, what? Huh? Okay, can we start? Okay. Anybody else joining? Okay, I'm going to start. Hey, how come? Hey, you all should know this, right? When two resistors are parallel, you always end up closer to the smaller one, correct? And especially if two extreme ones, 10 and 10K means it will always be almost 10. It will always be almost 10. Okay? You all should know this, huh? See, all easy stuff only, easy stuff only. Okay, next question. Very easy one, very easy one. Very easy. Very easy one. Okay, Thevenin's resistance is what? That means you imagine there's a source there, correct? How will the current flow? It will flow through 30, but here there's a short circuit, correct? There's a short circuit means you ignore the 20 and 10. Correct? You ignore the 20 and 10. So it's only 30 plus 40. Correct? Only 30 plus 40. 70. Okay, all happy? Okay, it's still anybody's game. It's still very early, so don't worry. This one should be straightforward. If you all get this wrong, I think I must tell Wising to go back, send you all back to EPP1. Okay, for two resistors in parallel, the combined resistors will always be smaller than the series one, correct? Will always be smaller than the series one. Okay? There's no doubt about that, it's always. Okay, very basic stuff, very basic stuff. Capacitor, what? Just think back on the expression for capacitor. Okay, capacitor is what? When the current flows, the charges build up, correct? And there's the electric field that forms between the plates. Okay, so the electric field is where the energy is stored. Okay? Okay, so all these are stuff, okay, even though you may forget a lot of the details, you still need to know your electronic stuff. As a firmware engineer, there's always hardware and software. Okay, so you still need to know some hardware stuff and circuit stuff to be good at what you do. Okay, so capacitor and inductor is opposite, correct? For a capacitor, the voltage cannot change instantaneously. For inductor, the current cannot change instantaneously. Okay, that is why the transient analysis is what? Always VC and IL, correct? For capacitor is VC, for inductor is IL. Okay, this one should be easy. Ideal transformer. What is the same? Yes, power, correct? The voltage and the current, the number of turns, all this will change. But for ideal transformer, the input power is always the same as the output power. Correct? Okay? I think got one more question, then after that will be programming. Remember the golden rules. What are the golden rules? Okay? For ideal op-amp, the golden rule is what? The input resistance is infinite. So there is no current flowing into the input of the terminals, correct? Remember? Huh? There is no current flowing into the input of the terminals because we say the input resistance is infinite. Okay, I think the next question onwards is C programming. Basic stuff. Should be easy for you. Also, one more question. Okay, so what is a filter? Do you remember your filter now? RC filter, correct? The RC filter is what? Just RC or CR, correct? High pass or low pass. Okay, if we just use RC filter by itself, we call it a what? Passive filter. You put in the op-amp, it becomes an active filter. The active component is what? It provides the gain. You filter and then you provide the gain, correct? So you can build a filter without using op-amp, that is a passive filter. But why you want to put the op-amp in? Because when you just build a filter, you attenuate both the noise and the signal. Alright, but I put in the op-amp, then I amplify the signal that I want. Alright, so that is the active filter. So you can still build a filter without op-amp, but ideally we want the active component. Okay, so next one onwards will be C. Still haven't, sorry. This one also should be easy. The plus minus V set, when does the op-amp go to plus minus V set? When you use in comparator mode, correct? When you compare V plus and V minus, when V plus greater than V minus, you go to plus V set, correct? You now go to negative V set. So plus minus V set is determined by your power supply. Correct? If your power supply is plus minus 9 volt, then it will be close to that. If it's plus minus 10 volts, it will be close to that. Correct? So it's related to your power supply of the op-amp. Okay, C programming. Should be easy, easy. Okay, so there are two. Hey, who say integer? Who select integer? Decimal numbers is those. Okay, you need. Okay, either your float or double. Both answers are acceptable to store decimal numbers. Okay, you can't use integer, you can't use character. Okay, so preprocessor directive, correct? Hash defines the preprocessor directive. Okay, most of the time we say use uppercase, correct? The uppercase is just a recommendation. Okay, it is a sort of unstated rule, correct? Unstated rule that we follow this convention. Okay, why? Because we do not want to confuse your constants with your variables. That's why we say put all uppercase. Okay, but if you want to put lowercase, it is still acceptable. Okay, it is not a error in terms of the compiler. So it is still a valid statement. Okay, so why is it 2.0? Okay, 10 divided by 4 is 2.5, correct? But it's integer divided by integer, correct? Okay, integer divided by integer, which will give me 2. Okay, the float is coming in after the division, correct? Because the bracket for the division enforces that I do the division first. Correct? If I wanted 2.5, what must I do? I must only float A or float B. Correct? If I only float A or float B, then the answer would have been 2.5. Okay, because then I would have forced the division to be a float-based division. But in this case, it's an integer-based division, then I cast it to float. Okay, but by the time I cast, the decimal portion already gone. Okay, so the answer is 2.0. Okay, so good. Most of you got it. So basically in Boolean algebra, what does it? Only 0 is false, correct? Any non-zero value is true. That means A is true, B is true. Correct? So when A and with B means true and true means it's true. Correct? Or with not of C. C is 0, so not of 0 will become 1. So eventually the answer is true. So the result for true is always 1. Okay, the end result is always either 1 or 0. Okay, true is 1, false is 0. So in this case it is true, so it is 1. Okay, so still got chance. Okay, most C compilers or no C compiler can detect logical error. Okay, logical error is your own code, correct? They can only detect syntax error. Okay, you forgot your semicolon, you forgot your bracket. Those are the syntax errors you can catch. Logical errors, you never run the loop for the correct number of times, you never put the correct condition for the if-else. Those are logical errors which the compiler does not know. Okay, so you cannot detect that. Okay, so what exactly is this? Alright, so when you say Arduino is an 8-bit controller, this ARM controller is 32-bit. So this 32-bit refers to generally what you call the data bus. That means how much of data I can deal with at any point of time. Okay, of course in most cases the data bus will also translate to address and control, but the relationship is always with the data. When I say it's 32-bit means I can deal with 32-bit of data at a time. 32 bits of data at a time. So that is what it refers to. Okay, so one more last question. I think last question is very easy, very easy. Straightforward, very easy. Okay, so the moment of truth. Okay, moment of truth. Okay, so can the three of you please come down? Edward, ZH, and Nigel. Who are y'all? Hey, come on up. Nobody comes to claim. Who is Edward? Edward who? Come. Then Nigel? You are? Nigel, okay, wait first. You are the first prize, wait. Edward, who is ZH? ZH? Please come. Okay, so like I said, third prize, second prize is one Arduino Uno. Thank you, thank you. Okay, so now for you, Nigel, would you like the mystery prize or the Arduino Uno? Mystery prize, you sure? Cannot change your mind, huh? Later got a box of chocolates, you cannot give me back. Very sure, huh? Okay, this mystery prize is only for today, not every day. Okay, the rest of the semester is all Arduino Uno only. Only first one got this. Okay, so you have to open up and show them what you get. Only for today, please, I don't expect this every time. It's a Samsung Galaxy earbuds. Okay, thank you. Okay? Only today, not every week. Okay, not every week, only today. Okay, so all happy? Okay, so remember, next week, please come to the lab. Okay? And I will open up the canvas. Okay, once your team is formed, you will go and register in canvas. Okay, so I'll see you all next week for the labs as well, labs and the lecture.